Hey guys, Brendonian Productions here, and welcome to yet another Python tutorial. In this tutorial, I will be talking about function arguments, specifically keyword arguments and variadic arguments. So let's go ahead and jump right in as per usual. So in the previous tutorial, I actually talked to you about functions. Let's define a sample function just to refresh our memory. So we have a function called f, and it takes arguments a, b, and c. And then we can just print a plus b plus c. And this will, of course, work with any string or integer because that is what works with the plus arithmetic operator. So this is the basics of function arguments, right? Pretty simple. However, you can also call a function by specifying the arguments directly. So we can say f, and then a lot of people like to put this in new lines, something like a equals hello, comma, b equals my, c equals dog. So you can see the exact same thing happens, except the function call actually looks a little bit cleaner, right? It's easier to tell what's going on, especially if you have many arguments. You want to know exactly which data you're sending to what argument. So that is kind of a nicety, especially when you're dealing with arguments that might not make sense to you. There's also another type of argument, right? So these are called positional arguments. There's another type of argument called keyword argument, which when you create the function, you basically specify a keyword and then a default value. And then when the user calls the function, they are required to provide the key in order to provide that variable. Well, they're not required. They can still pass it. Anyway, so let's go ahead and alter our f function to have a keyword argument. So we're going to say a, b, c. Actually, we'll make this a little more interesting, right? So name, age, location, and optionally species. But most people that call this function are going to be human. So we now define this function f to have a name parameter, an age parameter, and a location parameter. And we think that most people calling this function will have the species of human. So we've done the diligence for them, our due diligence, and provided a default parameter, a default value for the species argument. And this function is just going to print hello, name, age, from location, you must be, dot format, name, age, location, species. Okay, so that's our function. Now if we call it, we see that we can say f, my name is Brandon, my age is haha, location is United States, America, let's just say. So you'll notice that when we call this function, we only are required to provide 3 arguments. And if we don't provide the 4th argument, the default is used. But what happens if we provide this 4th argument? Right? So when we provide the 4th argument, that value is used, but we don't need to. Similarly, when we call this function, we can do the same thing. Name equals Brandon, age equals 100, location equals America, species equals insect. Now, what happens when we call the function if we want to mix these two calling mechanisms? So we want to say f Brandon 100, location equals America, species equals insect. No, actually for our 4th argument, we'll just say insect. So you actually see that there's some strict regulation about this. It says positional argument follows keyword argument. And that's because when you call a function, you must first specify positional arguments, that is, things that are just passed directly without a key. you must specify all of those first, and only after that can you specify keyword arguments, arguments with keys. Right. So if we actually change this this function call here that we just made, we're going to have to pass America directly, and then we can go ahead and specify a keyword argument. So you can see that there's a little bit of interesting things at play here, because yes, we want to pass location, but then the fourth argument, we then have to make it a keyword argument, right? Because we can't have any positional arguments afterward. Right. So this is the basics of keyword arguments. Keyword arguments are great for usually when you have default behavior that you think the user will always keep at that default. However, for some special cases, it might not be the default. What's a good example of a keyword argument, you ask? Well, there's several inside of Python's standard library, for instance. One of which is split lines. So when you have a string hello /n world, right? This is just a string with hello on one line, world on the next line. You can call split lines on it, and Python actually gives you a list of the value on each line. However, split lines actually takes a keyword argument. I'm not sure of its name, but it has a default value of false. And if you provide true, it will actually keep the new line characters in each item. So there's an example, right? Most people that split by new line don't want to keep the new line, but just in case you do, there's a keyword argument for you. All right, so that's enough about keyword arguments. Let's also talk about variadic arguments. So there are some functions that you want to define and accept multiple numbers of arguments. So for instance, what if you want to join a series of strings with a certain character? So let's go ahead and create that function. Join. Let's call it myJoin. And so for the first argument of myJoin, we want the string that we want to start with, right? The value. Let's just call it value. And then, well, actually we want the character. So the goal here is to take a list of things and join them with the character provided, right? So we'll take a character, a value 1, value 2, value 3. So one approach is to do value 1, value 2, value 3, right? However, obviously, when we're joining these values, we'll have to provide an infinite parameter list. So the next option is to make the user provide a list, value list. Right, there's nothing wrong with this. The user will just provide a list, and we can join each element inside the list. But this also requires the user to put their things inside a list, which can be a little annoying sometimes. So what happens if we just allow the user to specify an infinite number of arguments? Well, the syntax for this is *args. Well, you don't actually have to name it anything specific. The key is to include an asterisk beforehand, which specifies that it's a variadic argument. So we're going to define this function to print some debugging so we can see what's going on. Joining format args for str equals blank, for arg in args str plus equals char plus arg. Return str. Okay, so now we have this function myJoin, and let's test it out. MyJoin, we're going to join things with a comma space here. And then for our second argument, we're going to provide hello. So you can see a few things. One, our join function is not the best, right? Because if there's only one string, it just puts a comma at the beginning of it. That's fine, though, for demonstration purposes. The second thing to notice is that our joining print here revealed that *args is actually a tuple. So what happens if we provide multiple arguments? I did say that this is how you provide infinite arguments, so we should just be able to provide lots of things. It's a little confusing because I made the join character a slash or a comma, but so now you can see that we're in our function definition, it looks like we only take 2 arguments, but when calling functions, this function, we provided lots of arguments. And you can see that indeed the star args got parsed as a tuple here. And then we go ahead and join it with slashes. So that is star args, variadic arguments. Now, what about keyword arguments, right? What if we try to provide, what if we want to accept an unlimited amount of keyword arguments in our function? Well, this is done by the same sort of mechanism, except it's called keyword args. But the name doesn't matter. It's all about the double asterisk in the beginning. And convention is KW args. And what does this do? Well, let's go ahead and give it a shot. Because my join is a little hard to implement with keyword args, we're just going to say called with star args dot format args print called with keyword args dot format keyword args. So let's go ahead and get a look at what these args are. So we're going to call my join with character, who cares what this is. I'm just going to specify none. And then args here. So it gets a little tricky because args, you can specify a huge number of arguments. So how does Python know when the keyword arguments start? Well, just like I said before, we need to always provide positional arguments before keyword arguments. So let's provide a few positional arguments and then keyword arguments. So I'm just going to specify key equals value 1. I'll say key 1 equals value 1, key 2 equals value 2. So you can see that the star args got turned into a tuple of the values that we provided, and the star keyword args got transformed into a dictionary. So if you had a function and you wanted to accept any number of args or any number of keyword args, you could do so using this mechanism. Why would you want to do that? Well, say you're creating a wrapper function, right? So say we're doing, actually, there is a function os.path.join, which basically takes parts through variadic arguments and joins them with a path separator. However, we want to create our own os.path.join that basically prints some debug messages so we know what's going on. This is a trivial example, but basically we want to be able to pass any arguments that os.path.join takes, and we don't know what it takes. We don't care what it takes. We just want to pass them all the way down and print some debug messages. So we're going to say def myPathJoin, and we don't care what arguments the function takes. We just want to print calling os.path.join. Right? This is a trivial example, but it's worth it. Return os.path.join, and then we're just going to pass in the args and the keyword args. Now notice that we passed in the args and keyword args with the star and double star attached, whereas when we were printing previously, we did not attach the star or the double star. And this is because when you don't attach a star, right, so you just have the variable, it turns into a tuple. It is a tuple. And for KW args, it's a dictionary. So if we were to pass them here, we would be calling os.path.join with a tuple as the first argument and a dictionary as the second argument. But we know that os.path.join takes strings. And this would also be weird because we're not actually propagating the individual arguments the user passed down to the function. So in order to take the tuple and unpack it into multiple keyword arguments, we use the star here. So it's kind of like a double purpose construct. Similarly, in order to take a dictionary and unpack it into keyword arguments, you use the double star. So we now have this function myPathJoin, and if we call myPathJoin with hello world, just like we called os.path.join, you can see that we get the same exact result, except we have a debug message here. This could be kind of useful, right? Say we want to make a new function, and we'll call it time wrapper. And all it does is call a function with the given arguments and reports how long it takes. So so the first parameter for this would be the function to call, and then the arguments to actually provide to the function. So we say start time equals time.time, result equals func, args, keyword args, end time equals time.time, print call to func took. I'm not sure what units time is in, so I'm just going to say time. .format, and then we can say func.name here as the first parameter, and end time minus start time as the second parameter of this print. Return result. Oh no, what have we done? Okay. Parentheses, return result. Okay, so now we have this function time wrapper, and all it does is call the given function with the given arguments, and then it prints how long it took. So let's try it. Time wrapper, os.path.join, hello, world. So you can see this is quick, right? We were able to join these two paths and get the proper result in basically a very, very small amount of time. What if we do something a little more time consuming, like making a file? So let's see how long making a file takes. I happen to know that making a file, we can write to a file with open. So let's go ahead and do that. Actually, let's get a little more complicated and define our own function to write contents to a file and then time it. So def write file contents. And all we're going to say here is with open file as f.write contents. So if we call time wrapper with write file with the contents of hello world, my name is Brandon, we can see how long it takes to write this to the file. Oops. So you can see that, first of all, you can see that the result was nothing. And second of all, we got a nice 0.006 time for actually writing contents to a file on disk. So this kind of wrapping and passing in variadic arguments to subfunctions will be useful when we learn about a thing called function decorators, which is a very nice feature of Python. Thanks for watching. Bye-bye.